Okay. So introduction of loader. What are the different functions performed by loader? And then there are few types of loaders are introduced here. So we will see these loaders one by one. Assemble and go loader, general loader, absolute loader, relocating loader, then direct linking loaders. Okay. And then you have design of absolute loader as well as direct linking loader. As per the new syllabus, you have design of both the loaders in detail. So if you look, means whatever softwares you have learned so far, how they are working together, that I like to show here. So if you are giving source program as an input to your translator, so translator can be assembler, compiler. After translation, you will get some object code, right? That object code is available on hard disk, and if you wish to execute it, you have to load it in a main memory, from hard disk to main memory, where actual execution will happen. So who will do that job? Whenever you are giving command to execute that code, who will load that program in a main memory for execution? So here your loader comes in picture. So loader is a system software that loads your object program or executable program in a main memory and prepares it for execution. So this is your main memory area where your program is loaded and ready for execution. So your processor will read the instruction from this area and then this area, whatever I am highlighting in text. That location, your processor will read the data or instructions, and one by one instructions get executed. So this is how the loader will prepare your program for execution. But only loading in a main memory is not a job of loader, because while loading you have to prepare your main memory for loading that code, right? So that is also additional task performed by loader. So based on that, you can find some number of functions taken by loader. So this gray color area is highlighting the portion where your program is loaded for execution. The very first requirement is your RAM is having n number of slots or memory locations, right? So which should be allocated to current program. So your loader will search your entire free blocks in a main memory area, and depend on your input object code size, which is possible to fit in that particular box. So that box will be selected and allocated. So very first function performed by your loader is allocation. So it will scan all the free blocks in a memory and compare its size with your input program size, like object code. And if it is satisfying, we'll be allocating that block to a particular program. So allocation is the first step performed by your loader. Okay, allocating of space to the program in a main memory. Then after, your original program will have link with the header files or additional object codes. So all they need to be linked together. So linking is the process. That job is done by your linker. But if your linker is embedded with loader, then linking task will be performed here as a second step. So it will combine all 2 or more object programs or header files and combine together, and it will generate. It will resolve all the dependencies, all the references among all those object files, and then linked program is provided for further processing. Okay. So wherever you have a dependency, your one program is having dependency on another object code, they get linked. So binding is done over here. And now if your memory allocation starting location is different than relocatable source, or whenever you have translated a code, whatever the starting address you have assumed, if same is not available in main memory area, so different space is allocated, right? So both are having different locations, so some address dependent constants need to be relocated. So if you are able to recall unit 1 assembler, if you remember the symbol table format, the last bit is relocation bit. So that relocation bit is utilized here. If your assembler is saying this particular memory area is depend on starting address of your program. So this relocation process will change that address. Okay? So if you are moving your home from one location to, you are shifting from one location to other location. So what you have to do? You have to update your addresses everywhere, right? Wherever the dependency is. अगर आप कहीं करंट लोकेशन से न्यू लोकेशन पे शिफ्ट हो रहे हो, so your bank account need to be linked with new address, right? So that is what relocation is. So same is applicable to your programs also. So third step performed by your loader is relocation. All address dependent locations need to be adjusted according to the new space allocated to it in a main memory area. This process is called as relocation. And once allocation is done, all linking dependencies resolved, dependent addresses are adjusted, you're ready to load the program. So final job is load the program in a allocated space so that your execution will start. So every loader will perform these basic 4 functions: allocation of a space, linking with all the dependent programs or object codes, relocation, resolving all address dependent constants, and then actual loading of your program in a main memory area. Got it? So many times 2 marks question is asked, what are the functions of a loader? Explain them in brief. So this single slide is helping you to earn that 2 marks. In MCQ also questions are asked, what is the meaning of allocation, linking, relocation? So you should remember the concept. And then we are moving towards the types of loader. Yes?
Before going to the secondary memory, before I am saving my program to the secondary memory, all my macro files, all my libraries, or all my constant variable are already located inside the secondary memory, or what will happen?
Whenever you are compiling your program, only source code is translated. Okay, and something if you are linking with it, so it just inform this particular thing is depend on that particular file, but your compiler is not able to locate that. It is available but not able to locate. So your loader will locate them, link them, and then load it in a main memory. So at the time of loading, you are doing all this stuff. And if we separate out your loader and linker, then linker will be called first for linking all the object files, and then loader will load it. So that time it is already linked. You just need to load for execution. But right now basic loader functions are like this only. Okay. Got it?
Yes, ma'am.
You'll get more idea when we will start with the different types and along with their designs. Okay. So there are 4 or 5 types of loader that you have for study as per your syllabus. So we will start with simple one. So very first is called as assemble and go loader. Sometimes it is also called as compile and go loader. I'll tell you why the name is different. So assemble and go loader means what? Your assembly, translation of assembly program to machine code is done with the help of assembler. And assembler itself having ability to load that program. So आपका translation and loading done by single software, that is assemble and go loader. So loading job is added in your assembler code itself. Okay, that's why name is given assemble and go loader. First assemble and then convert. That's and then load it. So source program is given to your translator. Translator is assembler. That's why name is given assemble and go loader. So this loader will take your source program, translate it. So assembly program is the input. Translate it, and translated code is directly transferred to your main memory area. Okay, so look at the picture of main memory here. The gray shaded area is showing free blocks, and the white space is showing here the space occupied by some programs. So when you are loading your program for execution, your assemble and go loader is available in main memory itself. So that assembler is already there in a memory who is having ability to load the code. So unless and until your program is loaded, your assembler will remain in a memory. Even the translation is over, it is loading your program, that's why it remains in a memory. So if you see or if you observe the translator code or assembler code, It is occupying more space. Translation के बाद loading आता है, right? So loading is very small stuff compared to translation of complete translation. But as we have fused these two things together, your software size will increase and software will remain in a main memory. And that will create a drawback. Extra space is consumed by your assemble and go loader. So the idea is very simple. Your assembler itself having ability to load the program. So both assembly and the loading job is done by this loader. So this is how this pink color ellipse is highlighting the program that you have loaded in a memory for execution, and this blue color circle ellipse is highlighting the space consumed by your loader, assemble and go loader. Okay, based on that we can have this single diagram enough to understand how the working of assemble and go loader is, but it is having its own drawbacks and advantages. Okay, so the basic characteristic is your object code is directly stored in a memory after the assembly, and then single jump instruction. So your assembler will have a jump instruction which will transfer control to first instruction of your program, from where execution will start. Okay, what is the advantage? Implementation will be very easy because you don't have to search where the object code is, what are the dependent programs are, because your translator is doing that. So only adding single one or two lines to jump the instruction to particular location is very simple. That's why very basic advantage is it is very easy to implement. Assemble and go loader is easy to implement and it's simple in nature. But it is having a drawback. One drawback is I already highlighted. Extra space is consumed by your translator because it remains in a memory till loading get completed and execution begins. So memory is occupied by assembler is wasted because after translation job of assembler is over. But as we have fused these two tasks together, it will remain in a memory and space will be wasted. Second thing is, if you want to execute your program again and again, n number of time execution, so every time you need to retranslate the program because translator is doing job of loader, right? So हर बार आपका object code save नहीं हो रहा है, it directly storing that object code in a main memory area. So every time you have to retranslate the program and that is time consuming. Retranslation is time consuming. So that is another drawback of this kind of loader. Third thing is, if you are handling assemble and go loader, means what your input program is written in assembly language, right? If you want to combine assembly language and C program or Java program together, this kind of loader will fail because multiple code segment or program segment written in different languages are not handled by this type of loader because its translator is fixed. Assembler है तो आपका input assembly ही जाना चाहिए, right? And that's why it creates difficulty in handling multiple programming language segments. So these three drawbacks need to be overcome, and to overcome them, new or next loader is introduced. So just let me know if you have any questions related to assemble and go loader.
Ma'am, why assembler is occupying memory in the secondary memory?
Not in secondary memory, it is occupying space in a main memory. Because your assembler is also a software or program. Unless and until you execute it, you won't be able to translate your source code. Agree?
Yes, ma'am.
So when your assembler is running, it will be in a RAM. At the time of execution, your input program is translated and that translated code is loaded in a main memory again. Okay. So your assembler is translating the program, and at the end, after translation, it is having ability to load that program in main memory area. So it has to be there na, in running stage. Agree or not? Then only loading will happen. Yes. So when it is loading and running in your main memory, so obviously it is going to occupy a space, no? Yes or no?
Yes, ma'am, got it.
And if you separate out job of translator and loaders differently, means loader is separated from translator. So once your translation is over, assembly of your program is over, you can remove assembler, same space can be utilized for other programs, right? So assembler का code ज़्यादा है compared to loader. You write the loader. So space consumption will be more if you combine them together. But initially when they have started, the systems programmer have started writing the loaders, they have started with this kind of method. And now suppose instead of assembly program, if you are taking compiler as a program translator with input as a high level language program, so same loader will work as a compile and go loader. सिर्फ assembler की जगह आपका compiler and loader merge होगा. Task will remain same, drawbacks will remain same. Just a job of translator is different. That's why name is different. So sometime it is called with assemble and go loader. If you change assembler by compiler, it acts as a compile and go loader. So don't get confused with the names, okay? And generally, commonly you can call it translate and go loader. So कोई भी translator लो, उसके साथ loading का task assign करो. It will behave like this kind of loader. Okay, so with these three drawbacks, if we have to save a space by reducing the size of loader, we wanna handle multiple program segment, and we have to avoid retranslation. Okay, and these three drawbacks are overcome with the help of next type of loader. Here my animation is going a bit wrong, so please bear. So next type of loader is called as general loading scheme. It's generic compared to previous. So what the difference is? Here translation and loader, two jobs are separated. Translator will perform a role of translation and loader will perform job of loading, allocation, linking, relocation and loading. Okay. A source program is suppose written in C language given to a translator, which will generate object code. So this is what shown over here. And again another program, subprogram procedure given as an input to translator, it will generate object program too, right? If your first program written in C, second in Java, that is also acceptable over here, right? Because translators are separated, so you can write execute multiple translator and generate the object code, and that all object codes can be given as an input to your loader, right? And then loader will pull all those object code together, link them together, and then it will do the loading. So this pink color ellipse is showing the merge program, complete object code 1 and 2 together loaded in a main memory for execution. And that same time your loader is running, because loader itself a program which will run, then only your loading is possible. But as we have separated the translator from loader, so the translator program is not necessary to remain in a main memory. So that much space is saved here compared to previous loader. Okay, so translator आप remove करके same space loader के लिए use कर सकते हो या other programs के लिए use कर सकते हो. So compared to previous mechanism, some amount of space is saved over here. Okay. Then second thing is, as we are allowing translator separated from loader, you can use n number of programming languages and accordingly translation will be done. So more than one programming language segments are possible to handle with this type of loader. And once your translation is done, you can load that your object programs are generated, and then you can load them n number of times for execution with different inputs. So retranslation is avoided here. एक बार translation हो गया, no need to retranslate. Simply loader will load it, because we have separated the loader from translator. So only loading job is assigned. So आप pull कर सकते हो object program and load them in a memory. So all three drawbacks are overcome over here. No need of retranslation. Some amount of space is saved because we have separated the translator. And multiple object program can be generated with multiple translators. So multiple programming segments are possible to handle over. So general loading scheme is beneficial over previous loading case. Is given here. Your assembled or compiled code need to be saved and that can be loaded whenever required, okay, for execution. So it obviously overcomes all the drawbacks of your assemble and go loader or compile and go loader. So obviously whatever the drawbacks of previous is advantage over here. So compared to your assemble and go loader, general loader is having small amount of size, so definitely space is saved. No need of retranslation or reassembly unless you modify the code. If you modify original program, you need to retranslate. But if no modification, once your object codes are ready, you can execute them n number of times. Re-execution is easily done. Time is saved. And more than one source code procedures can be translated. So compatible code can be generated. More than one programming segments are possible to handle over. So all three are the advantages of this general loading scheme, which were the drawback of previous scheme. So all three we can overcome here just by separating the loader. Any questions related to general loading scheme? Any questions related to general loading scheme?
No, ma'am.
Third type of loader is absolute loader. Can anyone guess what is the meaning of word absolute? Forget about loader and all. Just tell me the meaning of absolute, what you understand with word absolute. Dictionary meaning of word absolute. Have you heard about the term absolute?
Complete.
Complete, okay. Any other inputs? Any other input from your side?
Perfect.
Perfect. Kuch? If we say absolute value, what is the meaning of it? So sometimes absolute values are not possible to change. These kind of values are fixed, complete, we cannot change. So with that context, absolute loader is developed. So what is the difference here? In case of your assemble and go loader or general loading scheme, translator translates the code with assumptions. Like in assembler, you guys have done a translation with a address given by your start pseudocode, right? If it is 100, आपका code storage start हो रहा है 100 line onwards, 100 location onwards. If I give 50 onwards, 1000 onwards, likewise. But it is not necessary that same location will be allocated after loading in a main memory. So that's why the address were relocatable. Okay. It's like your local address, which can be changed. But when we move towards absolute loader, here it is exactly opposite. It always works on permanent address. So जो भी address programmer देगा, with that address your translation is done, and your loader will make sure that same address space should be utilized during the loading in a main memory. And that's why name is given absolute loader. So during translation, whatever address you have assumed, same address is used to load the program in a memory. And that's why name is given absolute loader. So assembler outputs the machine language code or machine translation code So like your assemble and go loader, but difference is it translates the code with the location provided by programmer in advance, and same location is used by your loader to load it. So location is known in advance where my program will go. So can you guess what will be the drawback of this? As a programmer, I'm saying my program should be loaded from 100 line onwards in a main memory. So absolute loader क्या करेगा? 100 onwards ही load करेगा. So what is the drawback? Can you think? Yes. What if
Ma'am,
something is
as you
already
said,
there? Yeah, go ahead, go ahead.
exactly like as you said that from 100 onwards, I am asking the compiler or loader to allocate the memory. But what if my other data is already present at that memory? It will overwrite it.
Exactly. And that's the point. So as I am saying, forcing my loader to load it from predefined area. So if that area is already occupied by some other data or some other process, then there will be a data loss. And that is the main drawback of absolute loader. But implementation is very easy. Allocation job is already done by programmer because address is predefined. So we'll see advantages and drawbacks in next slide. So if you are using absolute loader, these kind of loaders are used by specific machines, or you can say specific embedded systems, where they are aware that memory location will be always free and it should be loaded in a same space. Okay. So allocation of the program, memory allocation will be done by programmer. Linking is also done by programmer. Suppose your main program is having link with the two additional subroutines or to some other programs. So that two other programs are also having address predefined by programmer. So you don't have to relocate, you don't have to link them separately. As a programmer, आपको पता ही है कि मेरा next procedure कहाँ पे है. So you can directly put the addresses over there. Okay. So linking is also done by programmer because programmer knows the addresses in advance. Only relocation is done by assembler if required. Probability is very less, but if required, means meanwhile calculation of address need to be changed, so that can be done by assembler, and only loading will be done by your loader. So as I said, there are 4 functions performed by loader: allocation, linking, relocation, and loading. So if you observe here, most of the work done by programmer or translator. So loading is only job done by your loader. That's why size of absolute loader is very small, and implementation is also very easy. You have a design of absolute loader, so we will discuss that. So see this simple example here. There are 2 programs, object files generated by your translator, main and sqrt. So my object files names are given in slide on left hand side, main and sqrt, square root. These 2 object files will be given as an input to your loader, absolute loader, along with some libraries. And what the absolute loader is doing? If my, as a programmer, I'm saying main routine should be loaded 100 location onwards. So see, observe the memory area. So main is written in white box, that is starting location is 100. There onward your main program is loaded. Similarly, I have specified 400 location for sqrt. So sqrt loaded 400 onwards. Observe the main memory area. So if already something is there, it is overwritten, data loss is there. Otherwise, an operating system should keep that area free. Okay. So this is how absolute loader works. So by observation, it's very easy for us. But how the loader will do that, we'll see in the next slide. So this is the space allocated to your main program, which starts from 100. This blue color shows the area allocated to sqrt starts from 400. So the address 100 and 400 is given by programmer. Start के बाद 100 दिया आपने. And same address is used here for loading in a main memory area. Okay. What is written in this main module and sqrt module? So sample code I have assumed for your understanding. So if my main program is having something like this here, my start statement is followed by 100, address 100, pink color mein 100 likha hai maine. Then rest of the statements, just sample assembly code is there randomly. And then end of the program, okay? So main routine is ended. Similarly for SQRT subroutine, I have written start 400. So blue color 400 is showing programmer have specified starting location here itself. Rest of the instructions, now you guys are aware how to translate them with assembler. End of SQRT, okay? So when you feed these two programs, now these are the two separate routines. So you have to assemble them with assembler separately. So first you will call assembler with main program. Its object code will be generated. Okay. Similarly, second time SQRT given to assembler and SQRT object code is generated. So look at the right hand side of your slide. The translation of object code along with location counter is given. So 100 onward up to 248 main program is there. SQRT 400 onwards up to 478. Okay. So this is what output generated by your absolute assembler. And these programs are given as input to your absolute loader. So when I specify 100 in original program, its meaning is given here. Your LC starts with 100. Okay. Similarly for 400, LC starts with 400. So translation is 400 line onwards. And then in while designing, I'll refer the same code and I'll show how this translated code is loaded in a main memory area with the help of proper algorithm. So what is the advantage of using absolute loader? I have already specified it is the simplest type of loader to implement, very easy to implement. But it is coming with lot of drawbacks. Very first is, as a programmer is going to allocate the space, allocation is done by programmer, right? So programmer have to specify all the addresses to the assembler. Definitely it will create headache when you increase number of subroutines. If you are having more than 1, more than 2, more than 10 subroutines, each subroutine starting address need to be remembered or what we can say returned by programmer, and that will be definitely a complicated job if your number of subroutine increases, because linkage will be done by programmer. So definitely programmer need to remember all the addresses, all absolute addresses explicitly, and that you are using to link with a subroutine. So subroutine linkage done by programmer by memorizing all those addresses. And if your number of routines increases, definitely task is difficult. Then next hurdle is, suppose you are having 100 subroutines. By any way you have remembered their initial addresses. Overlapping भी avoid करना आपको. And meanwhile, if you feel particular a module need to be updated by adding few lines, and if it is increasing length of the one of the segment or subroutine, rest of the subroutine may be overlapped. So आपका काम बढ़ेगा. That programmer need to reallocate rest of the space. So if you are making any change in any of the subroutine, because of which length of subroutine increases, rest all subroutine need to be reallocated with different addresses. And why to reallocate? You have to avoid the overlapping. Data loss avoid करना. So definitely a tedious job होगा. Okay. So up to this, any question? Have you understood how absolute loader is used, why it is used, and what are the drawbacks? Have you understood absolute loader? Any question? Yes or no?
No, ma'am.
Okay. So next part is design of absolute loader. So basically you have to understand when I say your load translator generate the object code. So right hand side of your slide is showing that object code, right? So object code should be written in specific card. For absolute loader, you have to write that code in a specific card. So absolute loader uses two types of card, text card and transfer card. So cards are having their specific format and we have to follow that. So text card format is given in front of you right now, which is having n number of sections. First one is card column, second content. Okay. So card column is first entry of the card is showing what type of card it is. Text card hai ya transfer card hai. You need to distinguish. So if it is a text card, card number should be 0. If it is a transfer card, card number should be 1. Okay. So card type आपका sign होगा with 0 or 1. 0 है तो text card, 1 है तो transfer card. Okay. That is called as text card identifier. Then second row is count. How many bytes of data you are going to transfer? Current card पे कितने bytes का data जा रहा है? 2 byte, 4 byte, 8 byte, 60 byte. So that count you have to mention here. Then 3 to 5. So basically this is a byte by byte information. So first byte is showing card type, second byte is showing count, third to fifth byte, 3 to 5, that byte information is showing address at what data should be transferred. So कौन से memory area में आपको ये data number of bytes उठा के paste करने, load करने. So that address should be specified here. And then your 6 to 7, that slot is empty right now. Okay, it can be used for validation purpose, data validation purpose, but right now assume it is empty. And then onwards 8 to 72. So this is the space of 64 bytes. So this 64 bytes space is utilized to store your actual object code, instruction or data. And then last entry is sequence number. So just look at this text card information and tell me maximum how many bytes we can store here. Actual object code. How many bytes of object code we can store maximum in one card? Guess कर सकते हो? First का entry is showing just a card number. Second में आपका count आ रहा है. Third is showing address. Fourth is empty. So if you look at 8 to 72, that area is of 64 byte only, जहाँ पे आपका actual object code load हो सकता है. So one card can hold maximum 64 bytes. If you are having more than that size, program size is more than 64 bytes. So what you are supposed to do? Multiple text card you have to use. More than one text card are allowed. And that is the reason your card sequence number are required. क्योंकि cards अगर randomly load करोगे, you are not able to generate required results. So my first 64 byte will be on first card, so my card number will be 1. Then rest of the 64 bits are on second card, third card, fourth. Likewise, sequence numbers are given 1, 2, 3, 4 onwards. So everyone have understood what is the meaning of text card? Suppose you are having 128 bytes of data. So one text card is not possible to hold it. So first 64 bytes will go here and rest of the bytes will go in a second card. Multiple text cards are allowed. But there will be only one transfer card. Remember, for every assembly code, multiple text cards are allowed, but only one transfer card is there. So text card का job क्या है? Hold the text. Object code hold करना है. And transfer card is helping you to transfer the control to first instruction, जहाँ से execution begin होता है. So transfer card first entry shows card type, that should be 1. You are not going to put any data over here. Transfer card में object code नहीं रहेगा. That's why count should be 0. You are going to transfer 0 bytes of information. Third to fifth bit is important here. Third to 5 bytes information. So address of entry point, where you are actually starting the execution. So that address is important and वही carry करने के लिए transfer card use हो रहा है. 6 to 72 bytes are empty, no use of that space. 73 to 80 is a card sequence number. So last card का जो भी number होगा वो यहाँ पे आ जाएगा. So this is what the format of cards are. Let me check the time. Yeah. So today I'll stop here. In next lecture, you have to remember these card types. I'll give an example. I'll show how the entry of each and every byte we are going to create and how that cards are used to load the program in a main memory. And that is actual design. Okay, so your absolute loader receives input in the form of some cards like text card and transfer card. Multiple text cards are allowed, but only one transfer card is there. So text card is holding your actual object code and transfer card is helping to transfer control to first instruction. So this is what the gist of today's absolute loader discussion. If you have any questions, please put it. Rest of the design we will discuss in the next lecture. So this example and all I'll explain in the next lecture. So this is what example that I'm going to tell in the next session. So all of you do one thing. There is a homework. Take a screenshot of this slide and all of you are requested to translate this code. Recall first unit, assembler pass 1 and pass 2 and create the object code, machine code in hex form for this code. इतना आपको करके रखना है because assembler आपको already पता है. So you just translate this program. Same object code we will use in next lecture. So all of you are informed to take a screenshot of this and do the needful. इसका object code आप मुझे भेजोगे by tomorrow or day after tomorrow. Let me know once your screenshot is over. Done?
Ma'am, I have a doubt. Yeah.
Yeah.
Ma'am, via text card, there is a last second section which is able to store only 64 bytes of information. Why is that so? Because it is promoting us to break the instructions into two parts.
Now reason is if we create a huge size, actually this absolute loader is again written or based on IBM 360 machine. So whoever the programmer for this loader, what they have thought is if we keep long size and during translation, if there is some interrupt or some event generated, high priority event generated, so translation will be broken or suspended. So it's better if we are safely transferring partial data successfully so that we can maintain the card number that this particular card is loaded successfully. And then in between we can handle some events or interrupt and then rest of the data can be translated without any data loss. So that was just a motive, nothing else. You guys are learning computer networks, right?
Yes,
CN पढ़ रहे हो, हाँ. So I don't know you reached to packet transfer or not. Why you are dividing your data in different packets? Why you are not sending complete data as a single packet? Multiple आपका message divide होता है ना multiple packets में, and then packet numbers are used to recollect the data at the receiver's end, and then data formed and then message will be given. So same logic is used over here. Just to preserve the data, or you can say data loss, avoid the data loss. And that's the reason. At a time, reading 64 bytes of data is not difficult for IBM 360 machine, and it will help you to load data byte by byte. Okay. So CN में अगर आपने पढ़ा नहीं होगा packet routing, in future you will learn. Same concept is used over here.